So for today's Digital Cafe, I'm proud to introduce Linda Schott, who will be talking to us today about detangling fact from fiction, the impact of manure on soil health in the semi-arid West. And Linda is an extension specialist and assistant professor with the University of Idaho. She specializes on addressing the needs of stakeholders in southern Idaho related to the impacts of nutrient and livestock manure management and other land management practices on soil health and water quality. She received her PhD from the University of Nebraska-Lincoln, go Huskers, in 2018, and her master's degree from Iowa State University in agricultural engineering prior to that. She is based in Twin Falls, Idaho. And with that, I'll turn it over to her.
All right, so I am Linda Schott, and I'm really excited to talk to you today. I'm just going to move right into it. So the title of my presentation is, about the arid West, detangling fact from fiction. But really my goal for today is not necessarily to educate you on the effects of manure and compost applications on soil health in the semi-arid West, but to introduce that the impact of management practices on soil health are nuanced, and the messaging that we give, depending on your audience, can impact how those messages are received when a producer or manager knows that the science does not apply to them where they're located. They kind of shut down and don't think it's necessarily applied anymore. So just to give a little bit of background of what my goal is, but also, you are going to learn about the impact of these management practices in the semi-arid West. So that is also a secondary goal, but it's just not the primary one. So I just wanted to introduce you to what is known as the Magic Valley, which is Idaho is a Western state. In case you didn't know, it's the other Iowa, the other potato state, which is a joke because people just don't know where anything is located. So the Magic Valley is this 8-county region that is highlighted in green. It's in south central Idaho. It is where almost the entirety of all agricultural production in Idaho occurs. So it's known as a high desert ecosystem. We receive about 10 inches of precipitation a year, 16% of Idaho farms, but 50% of the cash receipts for Idaho. It's a really high impact area. And that Idaho, ranks very highly for potatoes, but it's also in the top 10 for dairy, barley, hay, sugar beets, corn silage, and dry beans. And almost all of that production occurs in this 8-county region. And the reason they call it the Magic Valley is because traditionally our ecosystem looks like this picture in the top left hand, sagebrush ecosystem, desert. And when you add a little bit of irrigation water, it magically turns to this lush green farm ground. Which is just interesting. Anyway, so just some information of why it's called the Magic Valley is irrigation water is magic. And so this is a slide that I gave. So I started my position in early 2019, and really, I had come from Nebraska in the Midwest and had done my PhD work and even some of my master's work in soil health. Soil health was really gaining some traction. I was initially part of the Nexus very early on while I was still in my program. And so I came and I talk a lot about how manure can improve soil health over time by increasing soil carbon, increasing water holding capacity, decreasing compactability, increasing nutrient cycling and nutrient retention, decreasing both density and increasing aggregate stability, right? Like these impacts have been well established in the literature and all over the country, right? And when I got into it, I kind of thought my job when I moved to Idaho was going to be really easy. I was just going to copy and paste all the things I did in the Midwest to Idaho, and I was just gonna, make big waves. And I got into projects, and it did not work out that way. So spoiler alert, this ecosystem is just really different than the Midwest, and in fact, it's deterring farmers specifically from adopting soil health practices because they feel very behind. behind the Midwest in terms of what works for them, what are good metrics. It's sugar beets and potatoes in the system, so root crops, which are the enemy of soil health, because there's the act of planting and harvesting is sort of like an act of tillage, and that messaging was very I don't want to say hurtful, but very off-putting for this group of people. And so I started looking at a bunch of different metrics to see what was going to stick. So we had this large group of, we can pick and choose what metrics we're using based on the system, the specific system we're in, and being in the arid West. And so I just wanted to give very brief overview of some of the metrics. So I'm not going to go through every one of these items, just some highlights here of, can manure actually improve these things over time? And I'm using manure as just one practice. I've got data from other practices as well. So carbon, I did a really large project with active carbon, also known as POxC, with the sugar beet industry, but it was we evaluated almost 300 fields over 2 years for active carbon content. And they ranged, all sorts of tillage practices, all different, all the fields were going into sugar beets, but that meant that they were coming off of a wide variety of crops: potatoes, small grains, corn, there were dry beans, you name it. It was alfalfa, a lot of different things in that rotation. Lots of different tillage practices, different cover cropping, compost, no compost, manure, no manure, you name it, it was a factor in this study. And this is just as a metric, active carbon is really interesting because you can see the color change. So, but the darker the color, the less carbon there is. And so I did clearly pick and choose these photos so that you could see kind of what we're talking about. But strip till with compost had very high active carbon contents, which is shown on the far right-hand side, all the way down to conventional tillage and no compost. And so some of our results were, so we have this active carbon, and I didn't do this very well, and application of manure or compost significantly increased your active carbon. That's really great. And also pretty, it makes sense. You're adding carbon to the system, your carbon should increase. But one thing to note is that there was a pretty big difference between the number of fields that had compost or manure application and those that did not. And actually, the only way I could do the statistics and have some reasonable confidence was to combine manure and compost application into one category. So did they have application? Because there just weren't the numbers there to compare otherwise. But an other added factor, and I wanted this to pop up separately, but it's okay, it's here, is how you irrigate your field also impacts your active carbon, which makes sense. But this was also a very surprising result from this study. Is we had, so pivots are, those are what I've seen in Nebraska. I should have had a picture. Pivot irrigation, it moves in a circle. You have circular fields, they move pretty quickly. A wheel line is there, it's a linear move system. You have 3 or 4 of them or more on your field, and you move them every couple of days. And the way that they water are very different. So a pivot goes really fast and applies a small amount of water at a higher rate, whereas a wheel line applies a low rate of water, but over a long period of time before they move that system forward every few days. So a pivot, it doesn't get really wet, but it doesn't get really dry. And the wetting and drying cycle is pretty consistent. Under a wheel line, those fields go from, those areas go from very wet to very dry, depending on where they are in that watering cycle, which impacts the microbial community and how they're processing carbon, because microbes can only process carbon and be active in the perfect soil moisture. So the wheel line is just out of compliance of that perfect soil moisture for much longer. But this is an artifact that we also have to kind of think about, in the arid West is the effect of irrigation or not irrigating. You need water to actually process and work through carbon, right? So I just wanted to talk about the rest of this data is going to be from 2 studies that I collaborated on with the USDA ARS facility in Kimberly on a couple of long-term manure studies. So I just wanted to briefly introduce these because the rest of the results are going to be related to that. So we have one site that's called the cover crop study, but it's a split plot design, 4 replications. It's got 4 treatments. It's cover crop only, manure only, cover crop plus manure, and a control. But then there's also the impact of strip tillage and conventional tillage. And actually the study was initially supposed to have no-till versus conventional till, but our soils they're high calcareous. So there's a high lime content naturally in our soils. Our pHs are around 8.5. And it was so crusty at planting that the corn crop could not even germinate. It could not break through that crust. So we had to move to a strip till system to even get germination in the silage corn. There were 30 tons of dairy manure per acre applied in the fall, and then the crops were corn silage, and it was the cover crop, but it's actually a double crop. It's triticale, so it's what a dairy would traditionally apply or would plant to help remove more phosphorus from the system, and they would feed that triticale to their cattle. So that's the first study. The second study is known as the long-term manure study. Again, randomized complete block design. There were 8 treatments, so either annual or biannual manure application of 10, 20, or 30 tons of manure, which are traditional. So the 30 was actually like a normal amount of manure added, which is very high in these systems. And then 10 was a pretty low rate of manure that's applied by our producers. Tillage was disc and moldboard plowed. Yeah, moldboard plowing is still very prevalent in Idaho culturally. It's kind of crazy. Again, dairy solid manure, and the measurements that I'm going to show are in sugar beet. So it was in the sugar beet part of the rotation, but it was a 4-year rotation of wheat, potato, barley, and sugar beet, and it was in the 8th year of the study, which is why it's called long-term. That cover crop project was in the 5th year when I took these measurements. So it had been in these systems for a decent amount of time. So the first thing I wanted to mention, part of the study is that we did a Soil Your Undies campaign that was originally for producers. So we went out and buried underwear in their fields, but it was during COVID. So this was in 2020, and I was bored and looking for things to do that I was allowed to do in terms of travel, because the Idaho did shut down as a state. So I decided to put underwear in both of these replicated studies just to see what would happen. And so if you're not familiar with this campaign, you bury underwear. I'm sure you're aware of it. Mark it. You wait 8 weeks and you dig them up, and then you share your results. So we actually did it by weight. So we pre-weighed all the underwear, labeled them, and then when we took them out, we rinsed them off, dried them, and then weighed them at the end. And then we also took pictures. The visual analysis didn't go as well. I'm not a computer programming expert, but the weights were actually very telling, and that's what I'm going to present. So in that long-term manure study, this is just visually what it looked like. We have our control on the left, and that received no manure and no fertilizer. Fertilizer according to the University of Idaho recommendations. And then I grouped them into annual application or biannual application. There was actually no difference. So in this, I was able to show statistical significance of manure added to the system for annual and biannual. There was a much higher degradation than in the fertilizer or the control by using those weights. That's why I was able to do, statistics and whether or not that's a valuable tool, I don't know, but it was sensitive to manure application. And, you know, the idea is that these underwear are kind of showing microbial activity as those microbes are breaking it down, which is supported by, you know, a lot of literature that shows that when you add manure or compost, that carbon is readily available to microbes, and it does increase microbial respiration and activity. And I have what I'm going to call real data on that I'm not going to present that also supports that here. I just like to talk about the underwear whenever I can. And then in that manure and cover crop study, we saw something similar. You can see in this, in the bar graph that shows the weights, the two treatments that had manure were much higher than, although not significant, than the two treatments that did not have manure. Tillage had no impact, so I'm not showing that here. But you can see that the manure actually had a much larger impact than the cover crop did on that loss. And you can kind of see the difference, but you know, it's kind of nuanced in this study. And also one caveat of, you know, when you're the reduced tillage versus the tillage, obviously when you're burying the underwear, you are disturbing the soil. So that's kind of, again, those artifacts there of, is it really a no-till system because you had to bury it and you disturbed it and, you know, allowed those microbes, gave them more oxygen to break down. I don't know. So then moving on to more of these other things. So infiltration, I'm in the cover crop study. I'm showing, again, just the manure and cover crop. It's really interesting. So this is for two different methods of doing infiltration. On the left-hand side, right here, where all the bars are very similar, this is with a Cornell sprinkle infiltrometer. And then this over here is from a Saturo double ring automated infiltrometer. And there was no difference statistically in infiltration rates between any of the treatments, manured or no manure, cover crop or no cover crop, or tillage and no tillage, which I'm just not showing the tillage component. You can kind of see in the Saturo data that, you know, numerically there was a difference between the manured treatments and the non-manured treatments, but again, they were not statistical. And so this just is not an impact that we see in these soils. And then again, infiltration in that long-term manure study, we have again the control and the inorganic fertilizer, and then the rates of manure, either annual or biannual. And again, on the left-hand side is a Cornell, and then on the right hand is the Saturo. And again, there's no statistical differences between manure application and the control or the fertilizer. There's also, it didn't matter if it was applied annual or biannual or, you know, at a high rate or a low rate. There was just no statistical significance whatsoever. And this is a common, I don't want to say party line, but a common metric that we talk about is apply manure in, you know, decreases bulk density, increases infiltration, reduces runoff. And we just don't see that here. We do see, we saw a slight difference in bulk density after the 8 years of applying a lot of manure, but it really was not that much of a difference. And I'm not showing that data. We just don't have the same impact, especially in the, even, you know, these midterm 8 years of a ridiculous amount of manure had no impact. I'm just showing the runoff data this is from the Cornell sprinkle infiltrometer, the runoff rate and the rainfall before runoff. Again, absolutely nothing in that long-term manure study. And this potentially could be caused because we are in that study, it's still moldboard plow. So there could be so much, you know, agitation and that's happening in that study that could be impacting it. But with the rates that are applied here, you really cannot do that in a no-till system. So it does need to be tilled under, especially because we were using dairy, you know, stockpiled dairy manure, where you're going to lose a lot of your nitrogen if you don't incorporate it. And so that's, you know, that the benefits and risks and which one outweighs the other one. So in cover crop, we did not see any difference in runoff rate, but we did see the amount of rainfall or water that the soils would accept before runoff, but only between the two extremes of the control and then the cover crop plus manure. And you can see that the manure had very little effect. And it was just the two things together. So again, pretty disappointing. I have a lot more data from this that is equally disappointing. Again, so this is LT manure with aggregate stability. We did it two different ways, one with the Cornell sprinkler, setting it at different heights, which is shown on the right here, 1, 3, and 5 feet. And that's kind of to, different heights of sprinkler heads above the soil surface. And then on the left is the traditional wet aggregate stability method. And another giant disappointment. There is no statistical significance in any of this. There was no difference in the aggregate stability. I also did, the Slake's method and one other one that was a visual representation, and there was just nothing. The Slake test, what happens in our soils, especially for the Slake test specifically, is when you air dry it, it's almost like an artificial aggregation because it cements from the high calcium carbonate content. And so those methods just aren't appropriate. And, I would argue that the Cornell is very appropriate because of the different sprinkler head heights above, because that's, the majority of our rainfall during the growing season is by sprinkler irrigation. And we just weren't seeing anything after, again, a lot of years of this study. So in this study, 8 years, it was 8 years of, manure application before I took these soil samples. And then in the cover crop study, again, for the aggregate stability, again, in the wet aggregate stability, there was no difference in the mean weight diameter. You can kind of see maybe numerically things are increasing, but not enough for it to be significant. In the Cornell, we did see a difference in a couple of the heights. So when the sprinkler was 1 foot above the aggregate, so the least amount of force behind those water droplets, the manure cover crop and manure plus cover crop all significantly increased aggregate stability compared to the control. And then we kind of had some weird results in that third height, but in effect, the manure had no impact on that. So we saw a little something there, but still not a lot to speak of. And so then, my main conclusions are there are benefits to manure and compost shown in Idaho and Idaho soils, which can then be expanded to the arid, the semi-arid West, specifically those with high calcium carbonate and in these different systems, cropping systems. But it depends on the metric. And in the West, I really want to talk a lot about the water story because we're irrigating, it's expensive, we need water. But a lot of it is yet to be seen, especially at this, the scale that we're talking about. And I should also add that there were no differences in water holding capacity that we saw either. And so the water story isn't really the answer here. So we just need to be careful about how we communicate the benefits because there are differences between locations and it's not all, rainbows and sunshine, but there is some sunshine peeking through the clouds, if you, so to speak, in this system. So I just want to acknowledge this was a conglomeration of a lot of different projects and a lot of different people and different funding sources. And it was, there's a lot of things going on in Idaho for dairy manure work and soil health. I am happy to take any questions.
All right. So we do have some questions in the chat box. And I'll go ahead and start at the very top. For arid zones, manure versus biochar for all of the benefits that you're talking about.
Yeah, so for biochar, that's actually something that is a missing piece. There has not been a lot of work on biochar in our, our extensive crops here mainly. And one of the big drivers is we don't have a really great carbon source for biochar. So it's all being sourced from elsewhere. And so shipping and things like that. We are starting a project. So the University of Idaho and the state of Idaho in general received one of the Climate Smart grants for $55 million. And one of the management practices in that is going to be biochar application. It's just really expensive, and it doesn't make sense in our extensive crops. Maybe it makes more sense in greenhouses. And so I have not personally done that work. But yeah, it's definitely something we're looking into. But I also imagine that as a carbon, our soils are just really tough. It's just the base properties of our soils. So I would not expect there to be much of a difference from biochar, especially because you're going to be applying that at a much lower application rate than what you would manure or compost. But that is just my my gut feeling hypothesis.
All right, thank you. So then the other question that Ed asked is, you talked about some of the irrigation methods. Does Magic Valley use any kind of drip irrigation?
Very little. The only place that drip irrigation is really used is on corners, so pivot corners where traditionally they would be in hand lines, so solid line irrigation. They might switch to drip to alleviate pressure issues within the system, because often one single pump or well will be servicing 3 or 4 different, pivots and wheel lines. It's servicing a lot of irrigation systems that all have to kind of run at the same time. And so that's the only time that it's really used. It's used a little bit in the Treasure Valley, which is the Boise area, for onions. But for our extensive crops, really no drip. There's some, low elevation spray up, like so Lisa systems for pivots, but no real drip irrigation.
All right, thank you. Terrence asks, within the arid region of South Central Idaho, are they having siltation issues? And if so, what is being done to address those?
So we do have, I'm assuming you mean saline, salt issues. And
that's what I was thinking too.
We do have those pretty significantly in the fields that are closest to the dairy facility, that are receiving both lagoon water and solids. And there's really not a lot you can do for that, because your hands are tied in an irrigation system. So the way it depends on, water rights are all really complicated, but every producer is restricted in some way of how much water they're pumping. Either they only have a specific volume, or it's a flow rate, but only only during the growing season. So they don't have the window of opportunity to flush salts from the system. Or they don't have the ability to apply fresh water because they have to get rid of their lagoon water. So what really happens is they just kind of keep planting it to have a crop growing there, so they can continue to apply their lagoon water, but they're really not getting a good crop off of it because there's so many salt issues. It's really hard to come back from the salt issues here because it's irrigated. But I would say for the extensive crops and the fields, the dairy fields that are not really close to the facility don't necessarily have them. It's just one of the aspects that's monitored to make sure you can divert your manure specifically from those fields.
All right, thanks. Ed asks again, and I think I'm going to paraphrase this question because I'm not 100% sure I got it right. So correct me, Ed, if I'm not asking the question you're looking for. He's asking whether there are greenhouse gas or nitrous oxide implications that compare manure versus compost versus what I'm assuming is commercial fertilizer as the control.
Yeah, so there's definitely some big, I mean, we have very similar impacts of application on greenhouse gas emissions. And it's something because we have this Climate Smart grant that we are currently wrestling with, is when you apply manure compost, especially our compost. So our compost, producers that create compost do not add water, and they're not adjusting for carbon. So it's not actually, it's not a high quality compost. They are getting the temperature, the technical temperature that they need for it to be compost, but it's not high quality compost. So when you apply it to a field and then you apply some irrigation water, you're going to have a lot of off gas. And so on a field scale, it appears that you are increasing your greenhouse gas emissions. But if you look at the full system of where that manure would go if it wasn't applied to that crop ground, that's just something we're struggling with in general. And so you can check back with me I don't know, it does have implications, and it's something we're looking at. And further, we are doing a lot of work into encouraging producers, I'm sure you all are doing this too, to apply appropriate rates of commercial fertilizer, of inorganics as well, because everyone has an insurance policy, especially when your sugar beets and potatoes are what are making you all of your money.
Yeah. So another question is relating to nutrient losses from runoff, both with and without manure. Have you done that research?
I have somewhat done that research. The thing, it's really interesting. So in Idaho, because it's irrigated, as long as you're not under furrow irrigation, gravity fed, there's really no off-field losses from your nutrients. The one caveat with that is, a little bit of a caveat is our regulation for application of manure on frozen, so you can't apply it, but it's based on the air temperature. And so there is manure that is applied in the winter, kind of when it warms up, because we do get above freezing quite a lot, a decent amount during the winter. So there's a lot of potential for runoff that way, but the way our landscape is designed, there's really not a lot of loss. It's actually more of a concern is wind loss. So the wind picking up dry particles in soil and depositing them into our water, our river basin system, is causing a lot of phosphorus concerns more than actual runoff.
I think we tend to forget wind erosion until we get those terrible windstorms.
Yeah,
so
we definitely have a lot
point.
more wind erosion.
All right. So the last question I see right now, and if you've got any other questions, definitely put them in the chat box. Otherwise, we'll get to our breakout rooms here shortly. Do you have a difference between tillage for MWD?
There was no difference in tillage and meat weight diameter in aggregate stability, which was a real bummer. Because I thought if there was one thing, which is why I did not show the data. Again, so it's interesting because, when you reduce tillage in the East, it's you increase aggregate. It's very straightforward. You increase aggregate stability, you're maintaining carbon. And here you're maintaining carbon, sure, but our soils are so crusty and so low in organic matter. I should have started off with that. Our best soils are 3% organic matter, but realistically they are between 1.5 and a little over 2% organic matter. So it is very challenging to move to an actual no-till system because it's so crusty. There's not a lot of carbon there to help maintain structure.
All right. We did get one more question in, and I assume this is specific to your compost, since you said that it's not a good quality compost. What does the carbon to nitrogen ratio of that compost actually look like? And then is that compost actually matured since it's not got that ratio like you were suggesting.
Right. Yeah, so it's a really wide range. So we did a survey a few years ago, and it kind of ranged from 11 to 1 to 16, 17 to 1. Which is, I mean, on paper, it's really not bad. And technically the compost is matured. Because it had, so it depends. The actual maturity index is variable, and a lot of that depends on the time of year that the compost was produced. So compost that's produced in the, from a lot of our dairies are open lot, and so they scrape. And so you can kind of be producing compost all the time. But in the winter, because they're open lot, they're applying, oftentimes they're adding in bedding from, like different sources, barley straw, sometimes corn stover, some other carbon sources as bedding, sawdust. And so in that time frame, it's really high. The compost matures, it hits the more than just the optimum temperature targets, all of that, and it's just higher quality. And then in the manure that is composted in July is just absolutely terrible because it was dry to begin with. They're not adding any water. All they're really doing is drying it, and it may not be actually reaching maturity. And that's the issue, is the companies that sell compost, when they provide their compost report, they cherry pick from the best part of the year, not from the actual pile that the compost was collected from. And weed seeds are a really big deal here because of that. Our dairy producers are importing different feedstock from outside, so cotton meal, and other products from the Midwest and the South, and it's actually introducing new weeds into the state because we're not properly composting that manure to actually kill weed seeds all the time.
Sounds to me like you need some chickens to deal with some of those weed seeds.
Right. Yeah.
That's another topic for another time. So this person is then just following up with a question: did you actually do compost analysis to see that maturity?
So not in the studies that we have that we're applying compost, and we have quite a few. We send and we're gathering that compost at different times of the year based on application. We're sending those samples to Soil Test Lab in Moses Lake. Washington is the only certified compost lab in the Pacific Northwest. So they did that maturity analysis. We also do have the ability to do a Solvita test here, but we like to do the full, their full analysis at lab grade to actually get insight into what's going on seasonally